In this video, I'm going to go over a common type of AP Calculus position, velocity, acceleration problem. And in this case here, we're going to let v of t equal 1 over pi plus sine 3t represent the velocity of an object on a line. At t equal pi over 3, the position is 4. So in the first part of the problem, we're going to write the acceleration function. Well, the acceleration function is equal to v prime of t. So in this case here, we're going to take the derivative of v of t, and we have 1 over pi is a constant, so the derivative of that is 0, and then sine of 3t would be a chain, so the answer for this first part would be 3 cosine 3t, using the chain rule. All right, for the next part here, we're going to write the position function. So we know I'm going to call the position function s of t, and that's going to be equal to the antiderivative of v of t dt, which in this case here, we're going to plug in the velocity function. All right. Well, the antiderivative of 1 over pi with respect to t would be 1 over pi t. And then the antiderivative of sine 3t dt is going to be a u sub. So we're going to let u equal 3t. So that means that du is equal to 3 dt. So that means we're going to have a 1/3 du is equal to dt. So we're going to have a 1/3 sine u du. So the antiderivative of sine u with respect to u would be negative cosine u. So this is going to come out to be negative 1/3 cosine 3t, and then we have our plus our constant c. Okay, so we're going to have to go in and figure out what the constant is, and we're going to use the initial condition that they give us. So at t equal pi over 3, the position is 4. So we're going to say 4 is equal to, we're going to plug in pi over 3. So if we plug in pi over 3 into 1 over pi t, we're going to get 1/3 minus 1/3 cosine. If we plug in pi over 3 for t, we're going to get pi plus c. Okay, well, what is the cosine of pi? The cosine of pi is negative 1. So we're going to get 4 equals, so we would get 1/3 plus 1/3 plus c. So that means if we wind up solving for c, we're going to get c equals 10 thirds in this case. So that means my s of t function is going to equal, let's just write it up here, we would get 1 over pi t minus 1/3 cosine 3t plus 10 thirds. All right, for the next part, we're going to try this. At time t equal pi over 4, is the object speeding up or slowing down? Explain your answer. All right, so in order to determine if an object is speeding up or slowing down, what we have to do is we have to compare the signs of the velocity and acceleration. If velocity and acceleration have the same sign, either both positive or both negative, that means they're working together and it will the object will speed up. If the velocity and acceleration have opposite signs, that means they're working against each other and the object will be slowing down. All right, so let's check v of pi over 4. Okay, so we're going to plug in pi over 4. So we get 1 over pi. We know that's positive. Now remember, this is a non-calculator, so we can't just plug this into a calculator. So we would get 3 pi over 4. So we have to determine whether this is positive or negative. Well, in this case here, the sine of 3 pi over 4 is in quadrant 2, so this value would have to be positive here, and we know 1 over pi is positive, so that means that v of pi over 4 is greater than 0. Okay? Now we're going to do the same thing with acceleration. Now if we remember back from the first problem, the acceleration function was equal to, we took the derivative of velocity and we got 3 cosine 3t. So we're going to check at pi over 4 the acceleration. So we would get 3 cosine of 3 pi over 4. Well, again, we're in quadrant 2. What the difference here, though, is we're dealing with the cosine. So the cosine of 3 pi over 4 is negative, times that negative value means that a of pi over 4 is less than 0. So the answer here would be the object is slowing down. And so to explain your answer, we would say object slowing down. We just have to justify because v of t is greater than 0 and a of t is less than 0. Okay? All right, let's try the last part. Okay, for the last part, on the interval pi over 2 to pi, what is the velocity when the acceleration is 3? All right, so we know that the acceleration from the previous problem is 3 cosine 3t. So my strategy here is I'm going to set the acceleration to 3 and I'm going to solve for t. Okay, so if I divide both sides by 3, I get the cosine of 3t equals 1. So that means what I know about the cosine is the cosine is equal to 1 at 0 and 2 pi and every multiple of 2 pi. So what I'm going to do is I'm going to say, so 3t would have to equal 0 or 3t would have to equal 2 pi. Well, solving this one, I get t equals 0, but that is not in the interval that I need. But if I solve this one, I get t equals 2 pi over 3, which is in the interval. Okay? So that means I'm going to take that 2 pi over 3, and I want to know what is the velocity when the acceleration is 3. So I'm going to plug in 2 pi over 3 into the velocity, and I would get 1 over pi plus sine of 3 times 2 pi over 3, which would equal 1 over pi plus sine pi. And what is the sine of pi? The sine of pi is 0, so our answer would be 1 over pi. Remember, this is non-calculator, so we're just going to leave it in terms of pi. Okay? So that would be a pretty common position velocity acceleration problem after doing both derivative and antiderivative, because you need to know the antiderivative to do this type of problem. So I hope you liked the video. Please like and subscribe. Thanks for watching.